Oh my days. So, what's up, Joe Gamers? I just accidentally ended a clip for today. Hopefully, the last video today is gonna be about chain roll. But first, I'm gonna show you a proof for chain roll, but not in not in a way that people most see it. So this is a chain roll, if you forgot, and let me do this new chain rule for only one variable for now. I won't do it for the second one, but it's just to show you the idea of it. So we'll start with uh what do I start with? Alright, let's start with the fact that change in y equals f prime, oh not f prime, f a plus change in x minus f of a, because a change in x is equal to x plus h minus x, right? So that means change in y is this. Anyways, so that is change in y. And should be more specific, say it's just h, but whatever. Anyways, not change in x, but like, you get the point. Not change in x literally, but yeah. Anyways, so keep so let's define an epsilon that is equal to the difference between the the average rate of change and the literal rate of change, the derivative at a. And if we solve for f prime, wait, hold on. Uh, oh, okay, I see, I see. So, let's see, epsilon plus f prime a times change in x equals delta y, right? Yeah, that's right. So delta y equals change in x plus f prime a change in x. So basically it's saying change in y is the difference between the average rate of change and the literal rate of change times the rate of change of the x. Well, not rate of change, difference in x, the change in x. So basically, I was saying that limit of change in x approaching 0 of epsilon should equal 0, because as the limit approaches 0, it should equal f prime a right here. They should equal each other as change in x approaches 0. Because in this one, as we can see, this will equal to the top part, dy, and then this approaching 0 is just dx, and dx minus dx is dy dx equals 0. So yeah. So with that, so now that we know this is what we have, suppose another function u of g of uh x and a function y equals f of u, if you simplify it even more, it'd be f of g of x. This is where the chain rule is coming to be. So we define that, and so if we do the same process for this thing, For here, we get change in u equal fa plus change in x minus f of a, right? And that would, if we do it to the same thing for change in y, the change in y equals f a plus change in u plus minus f of a. Or this should be g, my bad. And we do the whole process again, but now we use this version. So change in u equals epsilon change in x, or maybe, yeah, it's change in x plus g prime a change in x, and change in y equals epsilon change in u plus f prime a change in, or is it u? Let me see this. Oh yeah, it's not the same variable, it's b. And it's a change in u. And these epsilons are different. Epsilon 1 and 2. And so basically, if you saw them change in u into this equation, you get epsilon 2 times epsilon 1 change in x plus epsilon 2 g prime a change in x plus f prime b and all that again. So it's more better to just say that change in y equals f prime b plus epsilon 2 times g prime a plus epsilon 1 times change in x, because they all got the factor of change in x. Yeah, so basically factor out change in u, and then factor out change in x from change in u, and you get this, right? And then we take the limit of change in y over change in, no, change in u over change in y. Or is it? Where am I at? Yeah. Wait. Oh wait, there's no more change in y. Change in u, change in x. Lim as x approaches 0. And then we get, well, we know that epsilon 2 is 0. You know, epsilon 1 approaching 0 is 0. And so all we're left with is
In her new self-help book, Jump and Find Joy,
f
#1 New York
prime
Times best-selling author and beloved
b,
former Today
which
co-host Hoda Kotb
b
shares her
is
most
just
personal work
g
yet, offering wisdom on
of
embracing life's twists and turns and finding
some
joy on the
a
other side. Written and read by Hoda
times
herself,
g
this
prime a
uplifting audiobook
from
invites
here.
you to take the lead and
B is
love
supposed
where
to
you
be
land. Get Jump and
g
Find
prime
Joy
a,
today, wherever books and audiobooks are
or
sold.
g of a is supposed to be b, or some value of it, but like you get it. So this is how you get the chain rule through that method. See what I'm trying to go. So because I just showed you that, if you apply the same logic to 3D two variable functions, the chain rule for them would be, see this? Scroll make sure I'm right. So the chain rule of a function, say, This isn't a helpful description. Hold on. Alright. So say z is a function of f of x of t y of t, where x of t equals g of t and y of t equals h of t, then that's basically saying that z dt, this is equal to the partial derivative. Oh, whoops, no, my bad. Z dx dx dt. Notice the difference. And the reason why this is partial and this is the real derivative. Also, I forgot to write the full thing. Oops. No. So this is partial, this is the full thing, because when you get the partial derivative of some 3D function, I'm scared of this. Hold on. It's gonna be bad drawing a 3D object. Can't never do that correctly. So say you got a 3D object like this, and say you got the derivative of here at this point. The partial derivative is saying that you took a piece, like you held a piece of the function. Oh, that's bad. You held a piece of the function still, like, oh, this is actually a bad example because it should be. So this is z, x, and y. I need to delete that little marks first. Z, x, y. So let's say I got the partial derivative where it looks like this. The partial derivative reveals a line or a cut, like a little section of the function. As you can see here, we're keeping one variable still, and that variable is y. So this is a partial derivative of x. Oops. So this is the partial derivative of x. The other way around would be this for y. But yeah. So we get the partial derivative of x. We reveal this line. Like since we held. Wait, is this a partial derivative of x or y? I think it's a partial derivative. Gotta be. Cause wait, this low key might be a partial derivative of x. My bad. Cause we're keeping x, but y is not changing, so I have no clue anymore. Let's say you cut out this section of the function. Wait, this is y. It is partial derivative of x at some y. Because we keep x and y still, and we just then we get these get this line. If y is still, wait, am I trolling or what? I might be trolling. Hold on. Oh yeah, I'm right. So basically, if y increase, then the rectangle will move that way or that way. So yeah, so this is the partial derivative of z to respect of partial x, and what we're basically doing with the dx dt is finding the yeah at this particular point of at some particular point of the of this partial derivative, we get the actual derivative, or not actual, but like the two-dimensional derivative, because this graph is two-dimensional. The partial derivative reveals this two-dimensionality of the 3D surface, and based on the chain rule, we multiply the derivative with the derivative inside, since x was a function of t and z was a function of x and y. But we're gonna care about the fact that it's x right now. Was a function of x of t, right? So it's equal to x prime t and z prime x of t, which we all know that z prime, well, if, let's z prime, I don't even know, z prime my butt cheeks right now. So c prime is this, I guess, with respect to t. Could just be partial. Or could it be said? Nah. That's why the partial is right here. Because z is a function of x. So you can't forget the fact that z is a function of x, even though we're deriving z with respect to t though. But x is still a part of the function of z. So you gotta account for that. The reason it's partial is because this t only represents one variable, and it's the variable that gets you from here to here. But dz and dx are its own separate thing. Yeah. So that's with that. For anything. Yeah, so dz dt, that's what it is. Since t isn't exactly represented on the surface, but rather inside the surface of the function that is made from the, I forgot what the name is called for this, but whatever slice this called is where dt arises, and z is still technically this surface. It's just a two-dimensional representation of z. So that begs the question, what's the difference between this and this? And honestly, I don't know. This notation just represents the slice.
Okay, buddy. Notebooks?
Yep.
Okay.
Lunchbox?
Yep.
Homework? Homework?
Anyways,
Double
I don't
checking?
know how
Good
I
call.
spent so
Just
much
like getting
time on
AT&T's
that.
best deal on the all-new
Oh yeah, I
iPhone
was
17
explaining
Pro,
something.
designed to
Anyways,
be the most powerful
so
iPhone yet. Learn how new and
say
existing customers can get the all-new iPhone 17
now
Pro on us with eligible iPhone trade-in, any condition. Most expensive plan not required.
x
AT&T. Connecting
of
changes everything. Requires trade-in of iPhone 13 or higher, excluding
x
iPhone
and
13 mini. Terms and
y,
restrictions apply. Subject to change. Visit
but
att.com/iPhone for details.
x is a function of s and t, and so is
Tired of
y.
just having a job? Train for a meaningful healthcare
So
career at
then,
American
what
Career
are you gonna
College.
do
Get
now?
real-world training and career services support to help you prepare for what's next.
Well,
Choose from 12 programs, including medical assistant,
now
surgical technology, and
it's no
vocational nursing.
longer
Some can be
for
completed in
some
under a
reason,
year.
it's no
Visit
longer D.
accfutures.com.
This D
That's
is now partial D,
accfutures.com. ACC
C,
cannot guarantee employment.
D, S, and also there's this. It depends on which partial you're getting, but now you're getting D, C, D, T is equal to the partial S.
Need to simplify HR across your company?
Plus
At
partial
Equifax, we
C,
help streamline HR
partial Y,
processes, no matter your
times
size.
partial
From
Y,
onboarding to offboarding,
partial
our tools help you integrate new
S.
employees seamlessly. Discover how to
Now
streamline
you're
your
gonna be
HR
wondering,
processes and stay compliant. Click on the link
doesn't this
below to get
just
started.
equal to
Equifax,
2
your
times
HR HQ for every
partial
hire.
DZ? Yes, and I'm saying, I don't know. They're two different functions, so you can't really cancel them like that. So, I mean, technically it seems right, other than the fact there's a 2 right here. But yeah, so you technically can't just do that. These are its own functions. Because y is a function of 2 of these, and z is just a function of x and y. But technically, because it can be partial to s and whatever. Yeah. And this is the same thing, but replace s with t. And I think that's about all of them. Maybe. Got one more to talk about. Hold on. Do something. Okay, after consulting ChatGPT, I realized that these are not like your traditional derivatives. Like if this was dx times dx dt, you could cancel them for whatever reason. Probably cause why not? But most probably cause like I honestly don't know. It's probably cause there are I don't know how to explain this, but can cancel each other normally like fractions because they just want to. Because changing y over changing x. But these partials aren't exactly changing y, changing x. Because this partial x, partial y, this partial x on the bottom is acting like it's because it's responding to the x in z as x and y and holding y constant, right? And then the partial x over partial s this s is responding to x where x
Hey Bellingham,
is s
Alan
and
Stone is coming for
t.
one night only.
It's
Don't miss out
making
on the Resilient
t
Project's
constant,
first annual benefit
where
show featuring
x
Alan Stone.
here
Thursday,
probably had
November 13th
s and
at the Mount
t
Baker
not
Theater.
constant.
Experience an
So that's
unforgettable night
probably
of
why you
music and
can't
impact.
cancel them like
100%
that.
proceeds directly support the youth and families they serve. Tap now to get your tickets today
Also,
and be part of the
I don't know
impact.
if I should show you the any I don't know. And also the DZDT stuff. The reason why this is D and this is partial
At
is
AT&T, we
because
guarantee
the
our
fact
network so
that
you can connect with the most
x was
important
a
people in
function
your
of
life.
one variable,
Hey, it's
which
your buddy.
directly
Wanna win some
translated to D to
Walk,
Z
walk it is.
being a function of
Staying
T,
connected matters. That's why in
literally
the rare
T.
event of a network outage, we'll automatically
But
credit you
when
a full day service.
x
Guaranteed.
is a function of S and T,
For wireless downtime more than
yeah,
60 minutes or more caused by
multiple
a single incident
variables
infecting
that
10 or more towers,
do
stay
not
connected to infected
where
towers
not
and or stop
one
outage.
variable
Restrictions and exclusions
controls
apply. See
everything. So now
atv.com/guarantee
C is
for full details.
indirectly
Domino's Best Deal Ever is back. Any
influenced,
hand-tossed
but
pan, thin crust, or
indirectly
New York-style
controls
pizza
S
with
and T,
any
where
toppings for just $9.99
previously when
online.
it's one
Plus
variable,
friends
Z
get exactly
directly
what they
controls
wanted.
T,
Pan pizza
because
with
you can
barbecue
probably
sauce, mushrooms,
simplify
and
X
mozzarella.
into just a straight and
Chicken,
X and
bacon,
Y to
onions,
simply just a
jalapenos.
function of X and T and of just T.
So what are you gonna get this
So
time? Order Domino's
practically
9.99 best
one
deal ever before
variable,
it's gone.
right?
Prices higher for some locations. Online
Because, let me see, f of x y then is equal to x. You might as well just say dt dx is equal to partial of dx. D after dt dx. You might as well assume this. Because y is not even in the function. So likewise, when both y and x and y are functions of t, f of x might as well just be just one variable. Or f of t more like. But since now this is two variables, just like how these were two variables, to get partials, you have to get a partial of both of them now. So yeah, there you have it. Also, there's one more thing. Just one more. I'm not gonna do practice problems with this because you're just plugging in stuff, partial derivatives. I'm not gonna do that. So, say we have f of x equal to 0. So we can implicitly say that that dy dx equals the negative partial of x with respect to x. And we get this from the fact that since f equals 0 and f is some function, I don't even know. Yeah, so I honestly don't know what happened to. Yeah, I don't even know how this happened. Where this turned into this. I don't know. But that is that, and it's useful. It's equal to fx minus fy. When you got a function of f, like you got x squared plus y squared equals 1, and you just make it into x squared plus y squared minus 1 equals 0, and we're gonna implicitly differentiate it, and then we'll get the answer through this. So that's what it's basically referring to. Yeah, that's it. So, yeah, hold on. I might copy this wrong. It was not. It was not this. It was dy. Not dy dx plus partial f partial x times partial x over partial. Dx equals 0. I don't know where it's come from exactly, but that's just how it is. Dx came from somewhere, I guess. I mean, it took dx with respect to dx, because we implicitly got x squared plus y squared minus 1 equals 0. We implicitly get the derivative of this of f with respect to x. You get like 2x. That's 2x would be the derivative right there. Partial to y of a function would be 2y. And then plus partial f to x would just be 2x. And we already got the partial. I don't even know where the dx comes from. Whatever. I'm